Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to be looking at all the key formulas that you're going to need for your A-level maths exam. And these formulas are all written in red. I'm going to give you examples of how to use each of the formulas, and these will be given in blue. You can press pause at any point if you want to try any of the questions before I give you the answers. And if you know any of the answers on key formula before I give you them, write them down so you're ahead of the game. Now, all the formulas in red you need to write down and make sure you make notes of, so you have got these for your exam and you can create yourself a revision list. You can either do it on cards or you can do it on a long list. It is up to you the format you choose to write these key formulas down in. Now, the first key formula we're going to look at is the formula for integrating x to the power of n dx. Remember your notation when you're writing integrals. So you need to put that curly s at the beginning. You need to write dx to show that you are integrating the function. You will lose marks if you do not state that you are integrating a function. So make sure you write clearly that you are integrating this function. This is the easiest level to start with, so all we've got to do is add 1 to the power and divide by the new power. So the integral of x to the power of n is x to the n plus 1, all divided by n plus 1. And remember, when you integrate, you must always add plus c on the end. So the first example we're going to look at integrating is 7x to the power of 5 dx. So all we're going to do is add 1 to the power of 5, which takes you to 6, divide by the new power, which is 6, which gives me 7x to the power of 6 over 6 plus c. The second formula we're going to look at is integrating e to the power of f of x dx. Now I'm looking at the most general rules that you can see. So f of x is just any function that you are given. Now to integrate, you are always going to look at this f of x function and you have got to differentiate this f of x function. Now when you differentiate, you multiply by the differential, but when you integrate, you divide by the differential. So you're always differentiating f of x, but when you differentiate a function, you multiply by the differential, and when you integrate, you divide by the differential. So in this case here, e to the f of x is e to the f of x, that doesn't change, and then we divide by the differential of the power, which is f dashed of x plus c. An example of this is e to the 4x take away 2 dx. Remember the notation, the integral signs and the dx's. So the differential of 4x minus 2 is 4 using the rule above. So the answer is e to the 4x minus 2 all divided by 4 plus c. The next rule is given in the OCR formula book, and we're looking at f dashed of x divided by f of x dx, and this is ln of f of x plus c. So the numerator is the differential of the denominator, and it is a key formula that people really forget. So please make sure you know how to do this one. So I'm going to show you an example where I've got the integral of 5x divided by x squared plus 1 dx. Now you can see that the top is the differential of the bottom, but it's not exactly the same. So the differential of the denominator is 2x because x squared plus 1 differentiates to give me 2x, but I've got 5x. So to deal with this, if I take the 5 outside the front of the integral, and I write 2x in the numerator because that's what I want to integrate. So I've got a 2x here because the differential of x squared is 2x. To make the question be exactly the same as what you started with, I need to have another 2 in the denominator here. So this 2 and the 2 in the denominator will cancel out, leaving me with the question. It is a little trick to help you to be able to do this. So take a factor of whatever is in front of the x outside the front of the integral side. Write down what the differential is of the denominator, so in this case it's 2x, and then whatever you've written here needs to then go in the denominator, and this will be the coefficient of your answer. So when I integrate it, I get 5 over 2 ln of the denominator, which is x squared plus 1 plus c. Remember to always add your plus c on the end. This next formula catches people out quite a bit. So you've got a function to the power of n, and then it's also times by f dashed of x with respect to x. So the formula for this is 1 over n plus 1 f of x to the power of n plus 1 plus c. So spotting this is quite tricky. So you've got to look, if you've got a bracket to the power of something or a trig function to the power of something, is what in the bracket the differential on the outside of it. If it is, then you're going to be using this rule. So for example, if I've got the function sine x cos to the power of 5x dx, is not written with a bracket, but you can think of this as being cos x to the power of 5. Now the differential of sine and cos are related, and I've got a sine here, so you can think, yes, it is going to work, but it's not exactly the same. So because if we differentiate sine, we get cos. So if we differentiate cos, we get minus sine. So there's going to be a minus involved in here because it's not exactly the same. So I've got to add that extra minus in there because the differential of cos is minus sine, not plus sine. You can see the rule says I add 1 to the power. So adding 1 to the power of 5 gives me 6. So I've got cos to the 6x, and then I've got to divide by the new power, which is going to be 6. So n plus 1 is going to be 6. Plus c will give me the integral of this. So just be careful with your signs if the function here is not exactly the differential of what is here. So just be careful. All these key formulas in red, please make sure you've written them down and highlighted. You will need to know all of these for your A-level maths exam, and you need to know when to use them and how to use them. We're going to look at integrating 2 more functions on this page. The first one, we're going to integrate the function f of x to the power of n dx. Now to integrate this, we need to add 1 to the power, divide by the power, the new power, and then divide by the differential of f of x. So we write that as f of x to the power of n plus 1 divided by n plus 1 divided by the differential of f dashed of x plus c. So we're going to look at an example. So we're going to integrate 4x take away 7 to the power of 8 dx. Now to do this, we need to add 1 to the power. So we're going to add 1 to 8, which takes you to 9, divide by the new power, which gives you 9, and we're going to divide by the differential of 4x take away 7. And the differential of 4x take away 7 is 4, so we're going to be divided by 4. So that gives me 4x minus 7 all to the power of 9, divided by 9 times 4 plus c. Then you just need to multiply 9 by 4 together to give you 36, and you can write that outside the front of a bracket as 1 over 36, or you could just write it as all over 36. It doesn't matter, they're exactly the same answer, remembering your plus c on the end. The next formula is not so commonly used, but you may come across it if you've got to integrate a to the power of x dx. This is a to the power of x divided by ln a plus c. So for example, if I've got 4 to the power of x, to integrate this gives me 4 to the power of x divided by ln of 4 plus c. On this page, I'm going to be looking at how to integrate all the trig functions, and these are the main 3 trig functions that you need to know, and you should be able to integrate these functions. So we're going to be looking at integral of sine of f of x dx, and I'm giving you the most general form to be able to integrate. Now, we have to differentiate the function f of x for all of these functions, and we're going to be dividing by f dashed of x. Now the differential of sine is cos, so the integral of cos is sine. So in this case here, the integral of sine of f of x dx is going to be minus 1 over f dashed of x of cos of f of x plus c. So for example, I've got sine of 4x dx. So the differential of 4x is 4, so I'm going to divide by 4. Remember, it's got a minus at the front, so it's going to be minus a quarter cos of 4x plus c. The next one I'm going to integrate is cos of f of x. So the differential of f of x is f dashed of x, so I'm going to do 1 divided by f dashed of x. Then I've got sine of f of x plus c. Cos of 5x is the example. The differential of 5x is 5, so I'm going to divide by 5, which gives me 1/5 of sine 5x plus c. The next one is slightly trickier, and we're going to be using the rule of f dashed of x over f of x dx, which was ln of f of x plus c on the very first page that I showed you. Now, tan x is sine x divided by cos x. Now, the top is the differential of the bottom with a minus sign. So the general rule is I get 1 over f dashed of x, ln of cos of f of x plus c. because the denominator, if I write tan as sine x over cos x, or sine of f of x divided by cos of x, f of x, the denominator is cos of f of x, which is what goes after the ln. The top is the differential of it, apart from there's a minus difference, so it's minus 1 over f dashed of x ln of cos of f of x plus c. Now we can write this in two different forms. So I could take that negative from the front and put it to the power. So I get ln of cos of f of x to the power of minus 1. And we know that cos of f of x to the minus 1 is the same as sec of x, or sec of f of x. So I get 1 over f dashed of x ln of sec of f of x plus c. Now the two in the red are the most commonly ones which are used. So you need to know the two in the red. You can write it in either form depending on what the exam question is asking you to do. The purple step in the middle is just showing you how to get from one form to the other form. An example of this is tan of 7x dx. So the differential of 7x is 7, so it's going to be minus 1/7 at the front, ln of cos of 7x plus c, or I could write that as positive 1/7 ln sec 7x. Now this last one is quite tricky to spot, and you will need to know how to do it in either form in the exam. So just remember that first rule, the top is the differential of the bottom, is how you integrate tan of f of x. Here we're going to look at integrating the reciprocal trig functions. So we've just looked at the normal trig functions, now we're going to look at the reciprocal of them. So we're going to look at integrating cot of f of x, sec of f of x, and cosec of f of x. Remember, we always have to divide by the differential of f of x in all of these functions. So the rule, 1 over f dashed of x ln of sec of f of x plus c is the integral of cot of f of x dx. An example of this, cot of 4x dx is the same as 1 over 4 ln sec of 4x plus c, because the differential of 4x is 4, so we're going to divide by that 4. Sec of f of x dx is 1 over f dashed of x ln of sec f of x plus tan f of x plus c. An example of this is sec of 5x dx. So I'm going to divide by the differential of 5x, which is 5. So it's going to be 1 over 5 ln of sec 5x plus tan 5x plus c. And the integral of cosec f of x dx is minus 1 over f dashed of x ln of cosec f of x plus cot f of x plus c. So the integral of cosec of 7x dx is going to be the differential of 7x, which is 7. So it's going to be minus 1 over 7 ln of cosec 7x plus cot 7x plus c. You will be expected to know these formulas and how to use them in your exam. Now the two formulas on this page are very closely linked. We're going to be integrating sine squared of f of x and integrating cos squared of f of x. And both of these are going to require you to use the double angle formulae to be able to integrate these functions. And they are quite common in the exam, so you really do need to know how to integrate these for your A-level maths course and your A-level further maths course. So the double angle formulae for sine squared of f of x is the same as a half 1 minus cos 2 of f of x dx. I have generalized it in terms of f of x for you. Once you've written it in this form, you will now be able to integrate the functions. Now you do need to make sure that you know how to write it in this form here. So you have got to learn that formula that sine squared of f of x is the same as 1, the integral of 1 minus cos of 2 of f of x dx. It is really important you learn that. So write it down, highlight it, stick in a bubble and make sure it stands out. From here, it is now easy to integrate both of these terms. So the integral of 1 is just x, and the integral of the minus cos 2 of f of x is minus 1 over 2 f dashed of x sine of 2 f of x plus c. So remember, you always have to divide by the differential of what is after the cos term. So the differential of 2 f of x is 2 f dashed of x. An example of this is integrating sine squared of 4x dx. So we're going to write it as a half 1 minus cos 8x dx. Then I can integrate both of these terms, so it's going to be a half x minus 1 over 16 sine of 8x plus c. The integral of cos squared f of x dx applies in a very similar way. So you just need to remember the double angle formula and rearrange it to write it as a half the integral of 1 plus cos 2 of f of x dx. You can see these two formulas are very closely linked. Okay, one has got a plus sign in the middle, the other one has got a minus sign in the middle. So they are very closely linked. You must learn this formula and you must learn this formula. If you do not learn them, you won't be expected, you won't know when it comes to the exam what sine squared is or cos squared. You won't spot it in the exam. So it's really important you learn the double angle formula in this form so you will learn to spot it. Now we can integrate. So the integral of 1 is just x, and then the integral of cos of 2 of f of x is 1 over 2 f dashed of x times by sine of 2 f of x plus c. Remember, it's a half of the whole lot of this. So we're going to look at integrating cos squared of 5x. Remember, the differential of 5x is just 5. So it's going to be a half 1 plus cos of 10x. So in this case, I'm going to integrate the 10x. So the differential of 10x is 10. So it's going to be a half x minus 1 over 10 times 2, which is 20. Sine of 10x plus c. These are really important to learn for your exam, so make sure you know how to do these two types of questions. The next three functions are going to be looking at integrating squared functions of sec squared, tan squared and cosec squared. So you'll need to know how to do each of these functions. So we're going to look at the sec squared of f of x dx. Now, in your formula book, they tell you the differential of tan x is sec squared x. So this is the reverse. This is the opposite of what is given in the formula book for the differential of tan of f of x. Remember, you always have to divide by the differential of f of x, which is f dashed of x, and you put your plus c on the end. So we're going to look at integrating sec squared of 8x. The differential of 8x is 8, so we're going to divide by 8. So I've got tan of 8x plus c. The next one we're going to look at integrating is tan squared of f of x. Now, to be able to do this, we need to write tan squared as an identity, and tan squared of f of x is the same as sec squared of f of x take away 1. Now, we've just learned how to integrate sec squared of f of x, so it's exactly the same as what we've just done up here. It's exactly the same. So that is 1 over f dashed of f of x plus the integral of, or sorry, take away the integral of 1, which is going to be minus x plus your c. So an example of this is tan squared of 4x dx. So the integral of tan squared is going to be the integral of sec squared 4x take away 1. Then I can integrate the sec squared of 4x to give me 1 over 4 tan of 4x. Then the integral of take away 1 is take away x plus your c. The last one is cosec squared of f of x. Again, this is in your formula book under differentiation. So if you differentiate cot of f of x, you get cosec squared of f of x. But remember, we've got to divide by this differential of f dashed of x. So I've got minus 1 over f dashed of x cot of f of x plus c. So more specifically, I've got cosec squared of 6x dx. The integral of the differential of 6x is 6, so it's going to be minus 1 over 6 cot of 6x plus c. So this is how to integrate all the squared functions for all the trig functions that you will need to know how to do. We're going to look at some more trig functions to integrate here. So the first one is the integral of cot squared of f of x dx. Now to do this, we're going to use an identity. And the identity you need to know is cosec squared of f of x take away 1 is the same as cot squared of f of x. Once we've got here, we now know the integral of cosec squared of f of x is minus 1 over f dashed of x cot of f of x. The integral of minus 1 is take away x plus c. So we can look at an example of integrating cot squared of 5x dx. Now the differential of 5x is 5, so we'll need to use that later on. But first of all, we're going to use the identity, so we're going to write it as the integral of cosec squared of 5x take away 1. Now we're going to use the formula to integrate cosec squared of f of x, or 5x in this case. Differential of 5x is 5, so it's going to be minus 1 over 5 cot of 5x, integral of take away 1 is minus x, plus c. The next one we're going to look at is the integral of sec of f of x tan of f of x dx, which is going to be 1 over f dashed of x sec of f of x plus c. This is the opposite way round to what is given in the formula book. So the formula book tells you how to differentiate sec of f of x. So you need to look in the formula book and be able to work backwards. Remember, always divide by that differential. So I'm going to look at integrating sec of 4x tan of 4x dx. The differential of 4x is 4, so it's going to be 1 over 4 sec of 4x plus c. Next is the integral of cosec f of x cot of f of x dx. Again, this is in your formula book as a differentiation, so you can look the opposite way to integrate it. So it's going to be minus 1 over f dashed of x cosec of f of x plus c. An example of this is the integral of cosec of 2x cot of 2x dx, which is going to be minus 1 over 2 because the differential of 2x is 2, cosec of 2x plus c. Now, substitution is guaranteed to come up on your exam on one of the 3 papers that you'll be sitting. There are some steps that you need to follow for its integration by substitution, and as long as you know the steps and you keep to them, you won't go wrong. So first of all, you need to choose your substitution. This will be given on the A2 maths exam. Then you need to differentiate this function that is given, and it will either be given in terms of u or in terms of x. Now, if you're given a u function, you will find du by dx. If you're given an x function, you will be working out dx by du. So just differentiate the function that they give you. Don't try and rearrange it first. Then you need to change the limits from x to be in terms of u if you have got limits in your question. Then you're going to substitute in and replace all the x's and the dx's and the limits in terms of u. So everything is in terms of u. Then you need to simplify your expression, make it much easier to deal with. Then you're going to integrate that new expression, and then you're going to convert back in terms of x, or you will put the limits in depending on what question you have been given. Now, in the exam, you will know you've got a substitution question because they will tell you the value of u or x, and they'll tell you to substitute it in. So in this question, we're going to use the substitution u equals sine x plus 1, and we're going to integrate the function cos x sine x 1 plus sine x all cubed dx. Now, to do this, we're going to take that u function and we're going to differentiate it. It doesn't matter whether you've been given u or you've been given x, or even if you've been given u squared or x squared. You just differentiate that. And if you've got a u squared term to differentiate, you will just get 2u du by dx. So don't be put off if it is not a u or an x term to differentiate in the first place. So this question here, I've got u equals sine x plus 1. So the differential of this will be du by dx is going to equal cos x. Now I need to rearrange this to get du or dx on its own. Now if we look in the question, I have got some information in this question, and I have got a cos x and I have got a dx in the question. So I'm going to rearrange this function here to get a cos x and dx on its own because the question has got a cos x and dx together. So du is the same as cos x dx. The next thing we're going to do is rearrange this to give you sine x. Now sine x is going to be u take away 1, and in this function up here I've got a sine x to substitute in. So we know the cos x and the dx is going to be replaced with du. The sine x is going to be replaced with u minus 1. 1 plus sine x is just the same as u, and then I've got the cubed term there. There are no limits to deal with in this question. So I've got the integral of sine x 1 plus sine x all cubed times by cos x dx. Now I have rearranged it to put the cos x and dx next to each other so you can see the whole of this last bit is the same as du. So replacing the sine x with u minus 1, the 1 plus sine x is the same as u. It's all cubed, and then we're going to replace the cos x dx with du. From here I just need to expand out the brackets to give me the integral of u to the power 4, take away u cubed du. Now I need to integrate each term separately, add 1 to the power, divide by the new power, so I get u to the 5 over 5, take away u to the power 4 over 4, plus your c. Now, if you had limits at this stage here, you would then substitute your limits in. So you would have changed your limits earlier and then substitute the limits in at this stage here in terms of u. Because we don't have limits in this question, I need to convert my answer back in terms of x. And we know u is the same as sine x plus 1. So that is going to be 1/5 of sine x plus 1 all to the power of 5. Take away 1/4 sine x plus 1 to the power of 4 plus c. Make sure you know how to do substitution because it is a key thing that you are asked in your exam, and you must know how to be able to substitute, whether you've got limits or without limits. Now, integration by parts is likely to come up on one of the exam papers that you're going to have to do, and it is a formula that is given to you in the exam. So the formula that is given is that the integral of u dv by dx with respect to x is equal to u times v minus the integral of v du by dx times by dx. And this is a formula you will be expected to know for your exam. So to be able to do this, we're going to look at an example, because in the exam they won't tell you that you are using integration by parts. If you're lucky, they will say integration by parts, but unlikely to. And you've just got to spot if you have got two things multiplied together, you are then going to be using integration by parts. And not only are you told that you've got to use, or you've got to work out you're using integration by parts, you've got to decide which way round they go, because the first one is not always u, and the second one is not always dv by dx. So you've got to choose which one of these two functions that are multiplied together. One is going to be u and one is going to be dv by dx. So we're going to choose u to be ln x. Now the reason we choose u to be ln x is because I can differentiate ln x, but I cannot integrate it. So I've got to let u equal ln x, which means dv by dx is going to equal to x squared. So differentiating u gives me 1 over x. So du by dx is going to be 1 over x. Then I have to integrate this function here to give me the value of v. Okay, so to go back to v, I've got to integrate, and the integral of x squared is add 1 to the power, so it becomes x cubed divided by 3. Now my formula says it's u times by v, so it's the top left times the bottom right. So it's the u term times the v term minus the integral of v, which is my third, x cubed, times by du by dx, which is 1 over x dx. So write down the values that you've got here into the formula. So the integral of x times ln x dx is equal to u, which is ln x, times by v, which is 1/3 x cubed, minus the integral of v, which is 1/3 x cubed, times by du by dx, which is 1 over x with respect to x. So I can just tidy up the front bit to give me 1/3 x cubed ln x. I could take the third outside the front of the integral sign, and then I've got x cubed divided by x, which leaves me with x squared. Now, this term here is easy to integrate. It's the normal rules for integration, so I add 1 to the power and divide by the new power. So I'm going to get 1/3 x cubed ln x, integrate this term here, add 1 to the power gives me x to the power 3, divide by 3, and the 3 times 3 is 9, so it's minus 1/9 x cubed plus c. Integration by parts is crucial. It is told to you in the formula book, so you should know to use it, but make sure you look at that formula, you know how to use it, and you know when to use it. So if you've got two things multiplied together that you're trying to integrate, always use integration by parts. You need to think about which way round you're going to let u and dv by dx be in order to integrate it. We're going to look at integrating using partial fractions. The key facts you need to know is that you need to factorise your denominator, then you're going to split the fraction up using partial fractions, and then we're going to integrate each term separately. Normally there will be some ln's involved when you're using partial fractions and you're integrating. So we're going to look at integrating the function 8x squared minus 19x plus 1 all divided by 2x plus 1 times by x minus 2 all squared dx. Now to integrate this, we're going to use some partial fractions. So I'm going to take the numerator, okay, so this fraction here, and I'm going to split it up over 3 parts. The reason it has to go over 3 parts is one part will go over the 2x plus 1, one part will go over the x minus 2 all squared, but because this is a repeated bracket, I need to put a c term in over x take away 2 because you've got a repeated bracket here. Now I've then got to work out what I've got to multiply each of these coefficients a, b and c by, so my denominator becomes the same on the left hand side. So I've got a 2x plus 1 on this first term, but to make the denominator to be 2x plus 1 times by x minus 2 all squared, I need to multiply this by an extra x minus 2 all squared. For the second term, I need my denominator to be what is on the left-hand side over here. I've already got an x minus 2 all squared, so I've got to multiply my numerator by 2x plus 1. The trickiest one comes from working this last term out. So I've got an x minus 2 in the denominator, but to make the denominator the same as what's on the left-hand side, I've got to multiply by 2x plus 1, but I've also got to multiply by an x minus 2. So my numerator will become a times x minus 2 all squared plus b times by 2x plus 1 plus c times by 2x plus 1 and an x minus 2. And that is going to be identically equal to 8x squared minus 19x plus 1. From here, I need to choose values to make x disappear. So I either need to make this bracket disappear, or one of these two brackets, which are the same as the first two brackets disappear. So to make x disappear, I could choose x to be 2, or I could choose x to be minus a half, which will make either of these brackets disappear, which will get rid of some of the terms. So I'm going to start off by letting x equal 2 to get rid of this first bracket here. So I'm going to substitute 2 into all the terms in this expression. So I've got 8 times by 2 squared minus 19 times 2 plus the 1 on the left-hand side. This first term becomes 0 because 2 take away 2 is 0. I've got to substitute 2 into the b term, so I've got 2 times 2 plus 1. And the last term will also become 0 because 2 take away 2 is 0, so the c term disappears. From here, I can solve to find the value of b. So you can type this into your calculator, rearrange, and find the value of b to be negative 1. Next, I'm going to let x equal minus a half. And by doing this, this will get rid of the b term, and it will also get rid of the c term because these two terms here will become 0. So I'm going to multiply by minus a half. So 8 times minus a half squared minus the 19 times minus a half plus the 1 is going to equal a times minus a half minus 2 all squared. The last two terms just become 0. So if I simplify this, I get 8 minus a half squared is a quarter. So 8 divided by 4 is 2. The minus times the minus becomes a plus, so I've got 19 over 2 and the plus 1 stays the same. Then I've got minus a half minus 2, which is minus 2.5 or minus 5 over 2. And when I square that, becomes 25 over 4, because a minus times a minus is a positive. I can simplify these terms together to give me 25 over 2 is going to equal to 25 over 4 lots of a. Then divided by 25 and multiplying by 4 gives me a value for a is equal to 2, which is the value of the numerator here. Now, I've worked out the values of a and b, but to find c is tricky because I can't let x equal a certain value and the brackets won't disappear because these two brackets are the same as what's in a and b. So what I need to do is to compare coefficients. And I'm going to compare coefficients of x squared. Okay, you could have chosen x or the constant, it doesn't really matter which one you choose. So if I'm choosing x squared, the coefficient here is 8 on the left hand side. If I expand this bracket here, I'm just going to be left with a lots of x squared. The middle term, there is no x squared term on the b term. And on the last term, I've got 2x times by x, which gives me 2x squared times by the c, which gives me 2c. Now I know that the value of a is equal to 2. So I can replace the a with 2, so I get 8 is equal to 2 plus 2c. I can then solve this by taking away 2 from both sides and dividing by 2 to give me a value of c is equal to 3. I can then substitute all these values for a, b and c into this expression here, which then means I will be able to integrate it. So the integral of the question that was given is the same as the integral of 2 over 2x plus 1 minus 1 over x minus 2 all squared plus 3 over x minus 2 dx. So these are all the terms here with respect to x. Now from here I can integrate each of these terms. Now I've got 1 over a function, so this is going to be an ln term, same for the last term. But this middle term is the same as minus x minus 2 all to the power of minus 2. So I need to add 1 to the power, divide by the new power of this middle term to be able to integrate this. So the first term will give me 2 lots of ln of 2x plus 1, but then I have to divide by the differential of this 2x, which is divided by 2. So those 2's will cancel out of the numerator, just leaving you with 1. This term here, if I wrote it as x minus 2 to the minus 2, add 1 to the power gives me minus 1, divide by the new power gives me divided by minus 1, which is the same as plus 1 over x minus 2. The last one here, I'm going to integrate the 3's at the front, ln of the denominator, which is x minus 2. The differential of 1x is just 1, so divided by 1 doesn't affect the value, and then you add your plus c on the end. From here, I can combine these two ln terms. So I can write this term here as the 3 as a power, so this becomes ln of x minus 2 all cubed. So this power can come in here. Then using the rules of logs, if ln a plus ln b is ln of a times b, so these two terms can multiply together, plus the 1 over x minus 2 plus c. So it is really important that you know how to integrate by using partial fractions. Often your denominator won't be in factorised form and you will have to factorise it to start with. So if you see a denominator that can factorise into brackets, then once you've factorised it into brackets, then you are going to be using partial fractions. So it's a tricky one to spot, okay, in the first place, but make sure if you've got a denominator that will factorise, then you are using partial fractions. It may help you to use long division if the numerator has got a higher power than the denominator. So just remember you can use long division as well to help you before you use your partial fractions. We're going to be looking at integrating using separating the variables. Now the key fact for this is that you need to put the y terms on the left, the x terms onto the right, and then you're going to put integral in front of both of the sides, and then you're going to integrate both of them. So an example of this is the function dy by dx is equal to x squared y. So if you've got a function in terms of x and y, you have got to separate the variables in order to be able to find the value of y. So what this means is I need to get rid of the y from the right hand side, and I need to get rid of this dx on the left hand side. So to get rid of this times by y on the right hand side, I'm going to divide by y. And to get rid of the divide by dx, I'm going to multiply both sides by dx. When you do this, remember you need to put integral signs on the front. Now, this is the same as dy divided by y, but it is much nicer to write your answer as 1 over y dy, because it is easier to integrate 1 over y dy rather than writing dy over y. So make sure the dy and the dx terms are always on the ends of the expressions. Then we're integrating x squared with respect to x, which is dx. So I've got to integrate 1 over y dy is equal to the integral of x squared dx. From here, I can integrate the left-hand side and the right-hand side. So the left-hand side integrates to ln y. The right-hand side, add 1 to the power, divide by the new power, which is x cubed over 3 plus c. And that is how we integrate using separating the variables. Now, this is a general solution at this stage here, but often we need to rearrange this to find a function for y. So to get y on its own, we need to do the opposite to ln y, which is e. So we're going to take e of both sides. So y is equal to e to the power of x cubed over 3 plus c. Now from here, I can use the rules of indices. Now x to the power of a times by x to the power of b is the same as x to the power of a plus b. So I can separate this out to be x to the power of x cubed over 3 times by e to the power of c, because when I add these powers together, that is the rules of indices that we have done at GCSE. So x to the a times by x to the b, x to the a plus b. You can just separate it out going backwards. From here, I've got a constant. So e to the power of any number is just going to be a constant. So we can replace this constant of e to the c with a capital letter of a. So my general solution is y equals a e to the x cubed over 3. A is just a general term that we use to express a different constant. So this e to the c has a value of a, so we can just write it here. The last integration technique you will need to know for your exam is integration using parametric equations. Now the formula for this is the integral between two x values that we'll call x1 and x2 of a function y with respect to x is the integral between the two t values when you substitute in these x values to work out your t values of y dx by dt. So it's like these dt's here can cancel, so you've got y dx, which is what you've got here, but you've got to add in the extra dt's to make it in terms of this third parameter. So an example of this, we're going to find the equation of a parametric equation of x equals t squared, and we've got a function of y equals t plus 1. We're going to be bounded by the x-axis and the line x equals 0 and the line x equals 3. So first of all, we need to find dx by dt. So my function x was t squared, so the differential of t squared was 2t. So you can see here I've got in my function dx by dt is going to be 2t. So I'm going to replace that as by 2t in this formula. Y is equal to t plus 1, so I'm going to replace the y with t plus 1. dt will just stay as dt on the end. I now need to convert my limits. So I need to work out my t1 and my t2 value. So my new limits, if x is equal to 3, so over here x is equal to 3, t is going to equal to root 3. So if x is equal to 3, t is going to equal root 3. And if x is equal to 0, t is going to equal 0, substituting into here just by taking the square roots of these values. Which means I'm going to be integrating between 0 and root 3 of my function y, which is going to be replaced with t plus 1, and dx by dt is going to be replaced with 2t dt. So I have got the integral between 0 and root 3 of t plus 1 times by 2t dt. I can expand the brackets, which gives me 2t squared plus 2t dt. Now I can integrate both of these terms, and they're going to be integrated between root 3 and 0. So I get 2 t, add 1 to the power gives you 3, divide by the new power is 3, so that's 2/3 of t cubed. The integral of 2t, add 1 to the power of t, which gives you squared, divide by 2, those two t's, the two 2's cancel, leaving you just with t squared, between root 3 and 0. You can now substitute in the values, so the top limit goes in first, so if I substitute in root 3 into this expression first, then substitute in 0, you will end up with 2 root 3 take away 3, just from substituting these values in. Remember, you will always take away the lower limit second, and if you substitute 0 into both of these, they will become 0. So you just end up with 2 root 3 plus 3. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!